Alright, so here's a quick little rundown of what's going to happen. We have two jars, jar 1 and jar 2. Both jars are different in size and shape, although both contain exactly 413 candies in them. Trust me, I had to count them all. The goal of this experiment is to see if the average values of candies guessed for each jar is different due to the shape and size of jars. Here's Antelope High School. Here's Vlad. Vlad's going to walk up to students and teachers and show them the jars. He's going to ask them to guess how many candies they think are in each jar. They will respond and we will record the data. With the data, we will calculate if there is any difference in the average amount of candies guessed for each jar. Then we will use that information to draw a conclusion and answer our question.
Alright guys, so we're gonna walk around, ask people around campus how many candies are in this jar, and then how many candies are in this jar. You ready? Can you answer your question for me real quick? Yes you do. How many candies are in this jar? You wanna hold it? It's glass, so don't drop it.
723.
What about this one? Just take a guess.
957.
Alright, Vlad. Just kidding, we asked you a couple questions for our stats project.
Okay, yeah, what is it? How many?
We're just asking how many are. Alright, so this chart right here. How many candies do you think is in here?
How many candies?
Do not see them.
Happy Friday, Titans. Next week's finals, so make sure that you get all your classes ready.
320.
On Wednesday, you're going to have
Alright,
your third
and
and
now
fourth
what about
period
this?
finals, and then on Thursday, you'll have your first and second period. Next week, we're also having cocoa and crayons, so if you guys need help, it'll be in the cafeteria after school. Alright, guys. Happy Friday. Have a great weekend.
I'm gonna say. The exact same. 320.
Alright. Hey, Bird, listen up. How many candies do you think is in this jar? Yeah, I'll take a guess. Just any guess. 500? Alright. Now what about this jar? 500 as well? That's a good guess. Alright.
Alright, welcome back. Hope you guys enjoyed watching Vlad pester every single person he could find to gather the data. As you can see on the screen right now, here's all the data that we collected. We got a total of 43 samples, and right here is the box and whisker plots for both jar 1 and jar 2. Now onto Kirat with the conclusion.
What's up, guys? I know that you guys are all in your finals right now. I already did mine last week, but I just want to let you guys know I'm still there with you in spirit. Let's get this grind on. Let's keep up this stats grind, okay? Let's go. I'll see you guys on Thursday through the video. So, error analysis. A type 2 error analysis is when we consist of concluding that there is a difference between the guessed values of the jar when in reality there isn't a difference. A type 1 error is when we conclude there is no difference between the guessed values of the jars when in actuality there is in fact a difference. Inference. The conditions for our inference t-test are the students are randomly selected from the population. The data comes from a normal distribution because our sample size n was 43 and that is higher than 30. And the sample of 43 students is less than 10% of the total population of students at second lunch. So this is basically just our test and our hypothesis. Our null hypothesis was that the mean difference would equal 0, otherwise known as the guessed value of jar 1 equals the guessed value of jar 2. Our alternative was that there was a difference between them, basically meaning that jar 1 does not equal jar 2. And we found a p-value of 0.0001, 0.0001, and that p-value at the 0.05 significance level is sufficient evidence to suggest a difference between jar 1 and jar 2, meaning that we can reject the null. So our final summary of the whole experiment in general and by itself is 43 students were asked how many jelly beans were inside each jar. The intention was to see if there would be a difference between the guessed mean jelly beans in each jar. The p-value being less than 0.05 means that there is a difference between the means that is guessed for both jars. This is basically just simply our data that we collected. Jar 1 is on the left side of each page, while jar 2 is on the right side.